So, hello everyone. Thank you again for joining us this evening. I'm Nina from Space for Impact. In this session, we would like to introduce quickly our partners in Switzerland who have been a great support and made this program possible, basically. But just before we start with this, I would like to remind you again of the big idea agenda this week, specifically the local agenda that we have here. So today, as you see, is the organizer presentation. Today, then at 6, please join us for our data workshop where we will present you our Swiss data set that we have for the session. Also, please stay for the cybersecurity session, which is by a Swiss NGO, ICON. Which will be very interesting. And then on Thursday, please also attend the team formation session and the project ideation. This will really help you to come up with your application, and you will be supported by our mentors. So please make sure you can make this session. Then let's get to our partners. We're really excited to have so many great partners on board. You can see them here. We have 3 different prize sponsors who will present themselves first today. And then also our many additional partners who will be presented to you as well. Our first speaker of tonight is Cyril Kubr, who's managing the European Space Agency Business Incubator in Switzerland and is sponsoring one of our prizes. Cyril, are you ready to share your screen? Yes, okay, good. Then I pass the floor to Cyril. Thank you.
So, good evening, everybody. Very happy to be here. Very happy to support this initiative. As Nina mentioned, I'm part of the European Space Agency's Business Incubation Center Switzerland since quite a while now, almost 5 years. And yeah, so what is the ESA BIC? Probably to start with, we're not alone. We're not alone in space, most probably, but also not alone here in Europe. We're part of a bigger network of incubation centers. You can see here basically the figures, 54 centers by now, with a yearly figure of supported startups of 150 plus. We do 20 here in Switzerland, 10 here in Switzerland per year. And so this sums up to a total of 1,000 startups that were already supported through this network. So what we're doing here in Switzerland is slightly different, no surprise, than at other places in Europe. So how does it work, basically? So we support startups that have a so-called space connection, so that use space technology, such as satellite data, but also, let's say, hardware developed for space and now used for terrestrial purposes, but also the other way around, technology that can be used in space now or in the future. We are, from the beginning, we were kind of a virtual / hybrid incubator. So it's not like everybody, all the startups come to us. Or the startups will be supported basically wherever they are in Switzerland, but come together for regular meetings, community events, demo days, etc., etc. Once selected, startups actually get a significant amount of financial support, so 200,000 euros, non-dilutive, over the whole time span of 2 years. That's how long the incubation period actually lasts. And on top of that, you get technical and business support of 80 hours through us, through ESA, and our partner network, which will be shown later. We select twice a year, an average of 5 startups, the totals in 10 startups per year, as mentioned. So who was or is part of our portfolio, basically? I won't mention every single startup, but you probably might recognize some names. Let's say the thing that makes us proud is that they joined mostly in a very early stage, often before the companies actually got founded or were just in the process of registering their companies or the legal entity, and we could support them very early on. You see a range of geography, but you see also a range of technology. We are very diverse, and you could also call us just, let's say, a high or deep tech incubator. So there is a lot of space, obviously, but not only. So what have the startups achieved so far? That just gives you a bit of an overview. I mean, the most prominent one is definitely ClearSpace, that many of you might heard of. I think it was a great success together with other actors in the ecosystem that we could support ClearSpace for, to get kind of a real space mission by ESA. So it was the first startup ever that was kind of awarded as a prime contractor, and it was from Switzerland. So I think that was a great success, but also other successes in terms of fundraising are mentioned here. So this is more kind of another view of a bit of the same. So startups received so far 6.4 million funding through us, but they were able to achieve a much higher figure through third-party money. So I think that's one success. The jobs created is a success. Obviously, that they also have all now a bit of substance, generate relevant revenue. So with this 50 plus startups supported by now, I think it all comes together already as a nice startup space ecosystem that we were basically able to co-create. So this is the partner network that you see. All those companies or institutions are part of our partner network. We have contracts with them. So it's not only a name dropping, they support us financially, but they also support us and the startups with in-kind support. So for example, if you need a wind tunnel to test, there are companies that provide this for free or for a discounted rate. There is business support. If you basically need to know how you want to industrialize your product, so a very wide range. And the interesting thing here is it's really the number one benefit, also ex post, if you want. So when you apply for our product, I mean, you're very much attracted by the money, but after the 2 years, you feel that the network that you also created or became part of is much more valuable. So this is definitely something. How does it work? Very quickly, it lasts 2 years. After the selection, you have 2 months basically to prepare yourself. Then you get your first part of funding, you get reassessed, and then you come to a second part of funding. All the information you'll find online on the esabic.ch, esabic.ch, sorry, that was German, esabic.ch. And what's also nice, you don't have to fully apply from the beginning. So if you have your DE, if after probably this hackathon, you can also get in touch with us. We talk first. You kind of have a pre-evaluation possibility. We show you the best ways how you can apply, etc., etc. So it's a very smooth process. Don't be afraid to contact us, and we'll try to help you or guide you through that process that might be a bit overwhelming in the beginning. So yeah, just quickly to the team. Who are we? You see my face, but also others. So we are 4 people based at ETH that are working on the project, but we also have some, let's say, contractors, subcontractors. So VentureKick is a part of that. The Impact Hub is a part of that. We also have a renowned space expert on board that helps us selecting and supporting the startup. So all in all, definitely someone who you can trust with your projects and people motivated to support you. yeah, so that's it. I don't think that there are any questions allowed now, but please reach out to us if there are questions, and otherwise all the best for the hackathon. And I'm really looking forward for interesting projects that might later also be incubated by the ESABIC. Thank you.
Yes, thank you again, Cyril, and also for explaining us a bit better how the ESABIC works and the success stories. As said earlier, you will be able to share, to ask your questions on Discord. Next up, we have Dr. Eva Maria Håkanson, the Innovation Officer at the University of Zurich Innovation Hub, that offers the winning team with an invitation to pitch for the professional coaching and additional financial support. Maria, are you ready?
Yes, I think so. You can hear me.
Okay, perfect. Then I let you share your screen.
So yeah, hello everyone. My name is Eva Maria Håkanson. I'm working at the University of Zurich, more specifically in the innovation unit at the Vice President for Research. And I'm going to present to you today a bit about what we're doing with the UZH Innovation Hub, and especially some space-related offers. So the UZH Innovation Hub, we have set up to foster innovation and entrepreneurship at the University of Zurich. And we do so by being active in supporting researchers and students that want to transfer their ideas into applications within 4 action areas. So we offer different type of training support. We offer access to infrastructure for innovation projects. And we offer network and advice, and especially also funding, and I'll come back to that later. We also strengthen innovation at our university by supporting and building up communities for strategic innovation topics, which you can see here: space and aviation, digitalization, research infrastructure, biomedicine and life science, and healthy longevity. And in the area of space and aviation, we have the UZH Space Hub, which is a community with members from over 25 research groups. And the UZH Space Hub have activities in 4 different areas. So we have experts in space life science, Earth observation, astrophysics, and aviation and drones. And here is an overview of projects and platforms in this area. So as you can see, it ranges from parabolic flight to drones to access to the ISS. And this is all activities that you can find within this UZH Space Hub. They can give you support with accessing these platforms. Within the UZH Innovation Hub, we have different funding programs to support innovative ideas and the transferring of research results to the market. One of those programs is the Digital Entrepreneurship Grants. It's a smaller grant to open for researchers, students, and employees of the university, which is there to make it possible to validate innovative ideas and for these people to get going and really remove the first roadblockers. We give 10,000 Swiss francs for a project of 3 to 5 months. Then like a following up format for more mature projects where you're close to or you're planning to fund a company. Spin-off from the University of Zurich is the Entrepreneur Fellowship, and those are amount to 100,000 Swiss francs and are given for a year. And you can find everything about application deadline and criteria for these funding supports on the website links as indicated in the slide. I also wanted to mention the Digital Entrepreneurship Program, as it might be interesting for you as a follow-up of this hackathon. We offer, on one hand, a bootcamp to develop ideas in teams that runs in the fall semester. And the Digital Ventures Seminar is a program where you really learn all the building blocks about starting up the companies in this space of digital innovation. And you learn from persons that are out there and have started their own companies. That runs in spring semester. And then here again, as a complementary to that, I also mentioned the digital entrepreneurship grants. So the people that would be interesting for you to get in contact with is, on the one hand, Oliver Ulrich, who is the lead of the UZH Space Hub, and you can get in contact with this UZH Space Hub and the community using this email address. You can contact me if you have any questions about our funding programs, and you can get in touch with Patricia and Catherine if you have any questions about the Digital Entrepreneurship Program. So yes, please go to our website, scanning this QR code, and you'll learn more about updates about innovation and entrepreneurship at the University of Zurich, and the different support that we offer. And I think it would be also interesting for you to visit the Space Hub website. There you also can sign up for the newsletter to get to know more about what's happening in the space sector around the University of Zurich. So thank you for your attention, and good luck with your projects.
Thank you very much, Eva Maria, for this presentation. Next up is going to be Dr. André Catana, who is the head of the startup unit at EPFL. This unit is also sponsoring an option to join the EPFL Launchpad to one of the best teams of this hackathon. André, are you ready?
Yes, so thank you, Nina. Hello, everyone. It's a pleasure to be able to present you here our startup Launchpad. So a very warm welcome. Our mission is clearly to support the companies, the startups that will build our future. And we're doing that from the very beginning, from the spark of an idea until the launch of the company, going through that intermediate phase where it's about the development of the technology, development of the teams, etc. We're focusing both on technologies and ideas, of course, but also on people. We all know that a promising startup is first about people, and we really focus for some time now a lot on personal development, soft skills of those who will launch these startups. How we are doing that? We do have two axes. We're addressing the two communities, the communities of the students and the communities of the researchers. These are two different communities with different needs. If we're going into more details on the student path, what we call the student path, we've put in place an inclusive program that starts with that ideation phase, the growing of that idea, the challenging of that idea, and everything which is related around soft skills, and I will tell you a little bit more about that. In the middle, you see that opportunity that is open for all our students to do a master thesis in their own startups. That's very interesting as well, and that ends with the last mile for students, which we've put in place a couple of weeks ago. It's called the Blaze Accelerator, and it's really helping for those companies to incorporate, to have their first clients. The tech path, this is where we have been building for a long time now, but we also structured it here in a way where it covers those phases that are necessary to go through the incubation phase. Just for you to know, but I think you already know, and a startup project takes a little bit of about 2 years of incubation in a lab before it can get traction from the market or from investors. So on the tech path, we have this first ignition phase is about exploring and validating a product or a service market fit, is about the booster, and I will tell you a little bit more about those services that are there to accelerate and de-risk our startup projects. And the last mile, as for the students, for those entrepreneurs coming with a deep tech project, we have the grants that are there for about 15 years now. For this tech launchpad, if we want to go a little bit deeper into what's in for you as a startup project, that ignition phase is about 6 months. We are funding that. The amount of funding is 30K. And as I mentioned before, it's really about validating a product market fit, validating a commercial path, exploring that go-to-market strategy. We are not starting here with just an idea. There needs to be an idea that is demonstrated in a lab, and we start from there. Then in that middle phase, after this ignition phase, we have a number of tools where we source out certain services, because it's not only about grants, right? So you really need to prototype, to design. You need to go to market quickly to get feedback from your customers. You need to make teams, and this is why we put in place a program, dedicated program for internships for that. And it's not so much for space application, it's more for life science here, a de-risker that is really well suited for life science sector. And the last phase, the liftoff phase, this 12 months, 100K salary for the leader of that startup projects within an InnoGrant. I mentioned that phase in between, so the acceleration, the booster phase, it is really key. We put that in place a couple of years ago. It's all about helping you to discover what your customer need, what their problems are. It's about shaping and readjusting your concept and finally make a minimum viable product that can really help you to raise that first customer traction or investor traction. One motto that is, one quote that we really is very close to us is the one by Guy Kawasaki that you can see here. He said, forget about the Excel sheet or the PowerPoint. If you don't have the prototype, you won't sell the idea. And if you get the prototype right, you may never even have to pitch. So it's a little bit provocative maybe, but it really shows what we're looking for is getting market feedback as fast as possible. What we put in place for that as well is a program that brings designers together closer to our startuppers. It is important because again, it's not to shape or to make a product nicer. It is to have something in hands that speaks to your audience, and the audience is your customer. And this is why we put that in place. It's a platform where you can have access to that, and we can match those two communities and fund projects that would help you move your project faster towards the market. The Launchpad internships are all about building the teams as everybody knows, we can't move successfully a project forward without bringing together a team. And this is an opportunity that is available for all our projects, bringing people with different backgrounds, with different cultures, people from business, designers, communication specialists, business developers, together with our scientists or students, in order to give value to the project and really allow building the first team of co-founders. Very quick example here of a journey in the Tech Launchpad. It's about a startup project that now is incorporated, raised about between 2 and 3 million. I don't remember exactly. It's called Arteria. It started with an internship. It went through a de-risker because it was about preclinical validation that was necessary, an Inno grant, and also design and prototyping to have all those feedbacks from the user, who in this case were clinicians. So you see here, it's really the right support at the right time. We really try to be as flexible as possible to respond to the needs, and every startup project has different needs. About students, very quickly, I've mentioned the change makers. This is a program that lasts about for 3 months. It's about coaching, mentoring. But everything here is to develop personal skills, entrepreneurial skills, leadership, how to give feedback, how to work in teams, what is important for you to make a sound market research. How do you talk to your customers? How do you pitch to your investors? So this is all about that. And it is for students only. The master thesis in your startup, I've mentioned that before, I will not come back into. And the last mile, this Blaze accelerator that we have established now a couple of weeks ago, 4 months. It's about really the last mile coaching. The goal here is really to have companies incorporated at the end of the accelerator. And these are a number of, you do have some names here. There are seven startup projects that enter this accelerator, and all these companies hopefully will incorporate by the end of this year. Some figures: last year, we've supported a certain number of startups, and 25 of them have incorporated. We've raised for 21 of them seed funding between 1 and 5 million. There are currently more than 40 projects in our Launchpad, and as an overall figure, last year, all EPFL startup raised close to 300 million. Last but not least, the team. Please connect with us. Please reach out. We're a small team. We're expecting you to write us, to connect with us. You can find us at startup@epfl.ch, or you can write to us individually. Thank you very much.
Thank you so much also for explaining to us a bit better how the Startup Launchpad works. I hope this is motivating for our viewers. Next up, I would like to present you Dr. Gregory Giuliani, who's the head of the Digital Earth Unit of GRID-Geneva and also senior lecturer in Earth Observation at the University of Geneva. Greg provided us with part of the Swiss data set, which we will present to you tomorrow, which is from the Swiss Data Cube. So making also these challenges possible, which we hopefully will soon hack. Greg, are you ready?
Yes, I do.
Okay, let me pass you the floor.
Okay. So I hope you can see my screen now. So thank you so much for the invitation, and hello everyone. That's a great pleasure to give you a short introduction on the Swiss Data Cube. This is one of the big research infrastructure we are handling at the University of Geneva to support the Swiss government, especially, but also all the research institutes and universities across Switzerland in terms of satellite Earth observation. So if we talk about sustainable development, and especially with the environmental aspect, to better understand these global environmental changes, our planet is under continuous observation from satellites since the 70s. So the animation is the fleet operated by NASA. But if we took a European example, the Copernicus program, which is the largest data provider and largest Earth observation program in the world, just one of the satellites, the Sentinel-2, it takes images of the Earth, of a given place around the Earth every 5 days, and it generates approximately 1.5 million images per year of the Earth's surface, this is a lot of data. And as I mentioned, the Copernicus program is really the largest EU data provider across the world, and it's stored already more than 250 petabytes of data globally. And there is clearly an increasing demand for free and open satellite data, as you can see on those graphs, and especially since 2008 with the advent of the free and open access data licenses, both for the European program or the US ones, for the Landsat. So you see really there is an explosion in terms of demand and use of those Earth observation data. So the advantage of using the satellite data, I would say there are many, but two of them, this is not only photos of the Earth, but you are observing not only on the visible wavelengths, but also in the infrared, for example. So it allows us to extract other information on the environment, for example, on the vegetation status and things like this. And the second advantage is the temporal resolution, and it's really a game changer. So if you look, for example, using Landsat 8, this is the American satellite together with Sentinel-2, the European one, you have basically on our latitude in Switzerland, an image of Switzerland every 3 days. So it means that basically we can really assess land cover changes through time in a very efficient manner. And we are close to monitor the Earth in real time. So it's really becoming a reality. But the big challenge that we have to face is how we can handle this large amount of data and extract useful information to support evidence-based decision-making processes. Well, there are many big data challenges related to satellite data. Obviously, the volume, the variety, and heterogeneity. You need also to have some scientific knowledge to understand what type of data you need to use. Usually, accessing and downloading this data can be quite difficult. Even to prepare the data, you need to correct the effect of the atmosphere and things like that. So there are many challenges. And if you come from the traditional remote sensing, I would say, community, usually what we do is we identify a footprint, we search different catalogs to access millions of images. And then once we have this data, we need to download them and pre-process them and things like that. So it's a huge and hard process. And then finally, you can maybe do some scientific work with this data. So with the use of the data cube technology, now we are able to facilitate the access to this data, and most of these pre-processing steps are done for you. So you access what we call analysis-ready data. So you don't have to spend much more time in pre-processing data. And the data cube, it's a kind of time series multidimensional stack of Earth observation data that can be efficiently analyzed. So for example, if you take the last time step in the data cube, you access a single traditional remote sensing image. If you stack the images through space and time, you have what we call mosaics. And if you look at the values of the pixels through time, then obviously you have time series analysis. So really the analysis-ready data concept is really the key, I would say, concept behind the data cube technology. And you spend really your time in doing what you are meant to do, so extracting information and generating information product. So the Swiss Data Cube is the second operational data cube in the world after Australia. So we have 37 years of data. It's updated every week. So we have the entire Landsat and Sentinel archive over the entire country. And if we we say that one pixel is an observation that we can translate in some environmental variables, we have more than 1,000 billion observations across the entire country. So just to give you an example, so this is the Valais, famous for the ski resort. And what we have done, for the decade between 1995 to 2005, for the winter months, we tried to estimate the snow cover extent across the Alps. So in red, you have the small percentage of the observation of snow cover observation, and in dark blue it's the permanent snow covered areas basically. And what you can see if you compare it with the next decade, you see that the dark blue areas are shrinking because there are less snow basically over the Alps, and we are able to assess and to quantify this decrease of snow covered of permanent snow covered area. So this is one example. A second one is related to drought. So this is a small lake, the Lake des Brenets, close to Neuchâtel at the French border. So it was during the summer 2017, so it's normal condition. And in 2018, during the summer, we had a huge drought over Switzerland, and you see that the southern part of the lake completely disappeared. So it was completely dried because of the drying condition. And if we do the same type of analysis we have done with the snow, but with the water, you can see also the frequency of observation of water for the summer months. And you see, you can have a look to the dynamics of the decrease of the water in that specific lake. The third example, it's related to modeling accessibility to urban green areas. So we developed a new methodology with colleagues from Eurostat to assess the accessibility. And behind the scene, it uses the Swiss data cubes and other Earth observation data processing capabilities to do this kind of analysis. In terms of potential applications, there are many applications where you can use the Swiss data cube and Earth observation data. And I just want to say that we are fully compliant with the FAIR principles, so the findable, accessible, interoperable, and reusable. So we want to facilitate the access to clean data because it makes data more reusable and integrable. And we are also aiming really to push for reproducible knowledge. So we are exposing all parts of an application, not only the data, but also the code, the tools we developed, and the results behind that. So we are really committed to that, and everything is free, basically using the Swiss data cube. And with that, I'm done. You can visit our website and reach out with the entire team of the Swiss Data Cube, and we will have also a presentation tomorrow with two of my colleagues from the University of Zurich and the University of Geneva. Thank you.
Thank you so much, Gregory, for this presentation and also for presenting us the Swiss Data Cube and the whole concept behind it as well. This was very interesting. We will now have a short break until 7 o'clock, and I hope to see you afterwards again so that you can learn more about our local partners. Thank you very much. Hello and welcome back to the partner presentation tonight of our local partners here from Hackathon Switzerland. Next up is Emanuelle David, the executive manager at the EPFL Space Center, which is going to tell us a bit more about the activities at EPFL and also about sustainability in space. Emanuelle, are you ready?
So, yeah, hello everyone. Thank you very much for being there. My name is Emanuelle David. I'm the executive manager of eSpace, EPFL Space Center. Tonight, I'm going to make you a brief introduction on what we're doing and our activities. So the mission of our center at EPFL is to run the three main missions of EPFL: education, research, and innovation. Our goal is to inspire, educate, and boost the next generation of top talent in space engineering and science, to promote and support space research in laboratories developing synergies, and all of this through innovative and visionary projects. And now I will tell you how we do this. In terms of education, at EPFL, we host a space technology minor with 80 students, and we supervise some student projects. Students also take part of interdisciplinary projects, And we have so far 6 teams working on space-related projects, such as EPFL Rocket Team, EPFL Spacecraft Team, Globot Hub, the Space Situational Awareness, Explore working on the Lunar Rover, and Asclepios working on analog mission for students made by students. Around research and innovation, we have 2 activity streams. One is around a research initiative on sustainable space logistics, where we are performing internal research, and we also initiate cooperation with Swiss labs and also international partners. Another work stream we have is to work on space-related research and also to boost space-related research within EPFL labs. This by providing information for fundings, coordination for interdisciplinary projects, and also management of projects with the industry when you have more than one lab involved. And in order also to promote all of these activities, we also do communication and outreach in terms of presenting EPFL space-related research in the media, but also being present in different events. Here, I wanted to show a bit more in details the activities of the students. So as I mentioned, there are several associations. So Calista is working on space situational awareness, meaning developing a intelligent telescope in order to track debris in space, and also an antenna for radio astronomy. The team Globot Hub is working on a robot in order to grow autonomously in an autonomous fashion vegetables in a closed loop environment for exploration. And this team is working in the frame of the IGLUNA project. The rover team is developing a lunar rover, and they will participate in an exploration competition, lunar rover competition this summer. The spacecraft team is working on developing a constellation of 2 CubeSats to study the composition of the upper atmospheres. Space at Your Service is an association working on outreach and to disseminate space to the broader public. And they have 2, I would say, main projects, one being Asclepios that I mentioned, the analog missions for by students, and also an activity called Astronomy on Tap to bring also space-related talks into bars and cafes in the Lausanne area. Last but not least is the rocket team working on different sounding rockets and participating in the Eurocode competition, student competition. And at last also the minor in space technologies. Students in the minor of space technologies can attend 26 courses in their frame of their master. They come from different profiles. They can come from all different schools of EPFL, as it's a minor. And then they learn about spacecraft design, mechanism, but also satellite imaging, avionics, and other topics like this. And then you can see here below the link in order to have more information on the course that are available there. And then, yeah, I decided I will not talk too much about the research part, as you have just after me a presentation from Devis Tuia, which is presenting, which is actually a great example of the kind of research that is performed at EPFL. And so that's why I will leave him to continue now. Thank you very much.
Okay. Thank you very much, Emanuelle, for sharing this presentation with us.
All right, you should be seeing a presentation now. Is that okay? Good, good. Okay, well, thank you very much for having me tonight, and thanks everyone for being live and listening to our presentations and to participate in the hackathon. I think it's we will have a great experience, and the topic is so nice. So it's, you know, digitizing green spaces. This is great. It's something very close to my heart. And in the next minutes, I thought I could share a little bit of my former experiences in working with green spaces, which in my mind are always red, as you can see in the background. So as a remote sensing scientist, we have this like professional deformation of seeing vegetation as red because it reflects in the infrared, and we like to map it on the red channel of the screen. So for us, trees are red. So, well, anyway, before showing some example of research, I just wanted to present myself a little bit more, as well as the laboratory. So ECO stands for Environmental Computational Science and Earth Observation. We're a quite new laboratory in the EPFL ecosystem. So we started in September last year, and we're located in Sion in Valais. So actually very close to the topic of some of the topics that will be proposed to you in the hackathon. And the lab is active at 3 levels. So that be Earth observation first, so dealing with satellites, aerial sensors, drones, smartphone, everything that acquires images or active signals of any kind. And what we do with these signals, that's the second angle of the lab, is that we develop machine learning approaches, so everything that has to do with artificial intelligence, and we try to extract information from these images, let it be through the development of machine learning approaches, or by developing software suites for human-machine interaction, where we empower people to collect data or extract information of relevance interactively. And finally, well, of course, we don't do that just for the pleasure of it, but we serve in major environmental applications in 3 main areas. The first being animal conservation, and then the second and the third, maybe a little bit closer to the topic of today, one being land use change, that can be very well applied into vegetation, and then alpine and Arctic studies, so studies of the mountains, snow, and vegetation in the Alps. So as the topic of the hackathon is about digitizing green spaces, I wanted to give my own take on the Earth observation angle, and basically sharing a little bit of experience in 2 families of sensors. The first being the active one, so the lasers. So research where we can exploit LiDAR data, which is a technology where you basically emit a signal from the sensor and record the time it takes to come back. And this tells you where the beam has been hitting something on the ground. So it basically gives you the position of the things where the beams hit before coming back. And the second one are spectral images. So images in the way we will refer to it. So it can be images from your phone camera, if you can see it because of my background, and or images that record reflected light at very different wavelengths, that allows you to have, for one single pixel, as you see here, a complete spectral signatures, which is how much light is reflected at the different wavelengths. And this will tell you a lot about biochemical and water absorption and all kind of behavior that that vegetation has, and that you are imaging from your airplane or your satellite. Okay, let's start with lasers. So with lasers, the type of data you get in the end look a little bit like that. I hope you can see my mouse. And so these are what we call point clouds. So every point is basically a return of a beam, and it will give you a 3D reconstruction of the forest. And when you have this incredible amount of points of the forest, it will allow you making 3D reconstruction, as you can see here. And then you can develop a number of approaches to extract information of interest. That can be, maybe the simplest will be the height. So you take the highest point you have, and this is the height of the tree. You can then start extracting single trees and calculate volumes, or the width of the trunk, and you can then extract all kind of information about the forest using this data that is pretty geometric. if you then take this geometric data and at the same time you take images from airplanes or from satellites, I mean mostly from airplanes because of the resolution, maybe your data will look like that. And for each species that you see in a different color, you will be able to see how differently they react to light in the different portion of the spectrum. And this will help you basically characterize the different species of the trees, as recent research has shown. So you can take this satellite data and then start to for every pixel or for every single tree, try to tell me which species that is, which is very helpful for forest management, for example, or wood, timber, and you name it. Some people have been doing that in urban areas as well. So using, for example, Google Street View images and photographing the trees from the Google car, then you can cataloging all the trees in the cities separately one by one and try to see which species they are, or then measuring all kind of things of interest about the trees in the city. So this is like very, very timely and exciting research that is happening right now. And maybe in the hackathon you want to go along this direction. A last one I wanted to show you will be then the next step. There will be working on changes. So looking at how much the forest has been changed over time. So if you have a time series of data, which I know you will have for the hackathon, maybe you want to look at how much the forest has grown, how much it has been cut, or like in this case, after a forest fire, which surface has been burned and we'll have to recover. And then you can look that using different satellites. If you see this, like A and B are taken by Landsat 5, which is a kind of, historical satellite, but still in use. And then Landsat 8, which is the latest of the series, then can give you almost timely concurrent series. And then you can really look at the recovery of the forest over time. And that's, at least for me, that's very, very exciting. So, yeah, I mean, long story short, there is a lot to do with satellites in forest area, and I wish you a lot of fun and good luck for the hackathon. And yeah, thank you very much. And these are all the wonderful people who work in all these projects in my lab. Thank you very much.
Thank you very much, Devis, for this interesting presentation of all the research projects out there and all the possibilities that Earth observation has to offer for us. Next up will be, our next speaker will be Dr. Claudia Röösli, who is the head of the National Point of Satellite Data at the Remote Sensing Laboratories of the University of Zurich. Claudia, are you ready?
Can you see my screen? Perfect. So thanks a lot for this introduction and also for the invitation. Also being part of this nice hackathon, I hope so. So as Nina said, I'm the head of the National Point of Contact for Satellite Data. I will explain you in a second what that means and what this is. So in general, we are here as a public service of the federal government for Swiss organizations and people. So what we do, we are distributed between two parts. So we are at the Remote Sensing Laboratory where I am working. So it's at the University of Zurich. And there we do free scientific consulting on any question you have regarding the use of satellite data. So whatever problem you have, be it for research and development, education, for industry, for whatever, for your private use, when you want to look at your house on a satellite image, you can just contact us and ask a question. And the idea behind is actually to use, to foster the use of this Earth observation data, so EO data. On the other side, there's also a National Point of Contact part at Swiss Topo in Bern. They're more dealing with the operational part. So they provide customer support, satellite tasking, and everything that is related to high resolution data as well. So meaning when you want to buy a satellite image that has a very high resolution, you can go there. In general, and as a summary, our customers are you, more or less. So everyone who is interested in using a satellite images and satellite data can come to us to see us, and we can help you. And this is also actually why I'm here, and I will also be presenting tomorrow in a presentation the use on the satellite data, and will also be part of the main hackathon once in a while. So it's not the last time you will see me on the screen. As I said, we are in general a team of 3 at the University of Zurich. We are financed by the Swiss government as well as the part of Swiss Tapo, but you will mainly have to deal with the part of the remote sensing laboratory. So for instance, on Thursday, Isabel will also take part in the event in the evening. So the questions we are normally dealing with, or we are helping with, is in general, most of the people, they don't really know what is Earth observation and remote sensing. On the other side, now, what types of satellites are around the Earth, orbiting and looking at the Earth's surface? What can they tell you? What can you learn from satellite data? And then, of course, most important, how you can access and process this different satellite data. And even more important, which one do you want to access, or which one is needed for your idea in your mind? And this is exactly what we will answer or introduce you tomorrow, and of course during the hackathon, that you can really bring your ideas and work with the data in a most efficient way. In our work, we're mostly dealing at the moment with these 2 guys, which will be the focus of the hackathon as well. Maybe some of you already knew the faces. So they're mainly the name-giving people for the Copernicus program and the Galileo. So Copernicus is a huge program of the European people, or the European government, and you will working with this data mainly, in addition with Galileo, which is actually the same as you know from the American GPS system. So it's the European navigation system, which is has been built up the last years and is now operationally in use. So when you want to use what we call GPS data or GNS data now, when we use different systems, you can also use the European system, which is Galileo. So in general, you can see on the left, so there's the Galileo constellations, which contains around 32 satellites orbiting around the Earth. And then on the other side, on the right side, you can see the Sentinel fleet. And during the hackathon, we will also use this Sentinel fleet satellite data. So if you see here, we have 6 satellites planned. At the moment, not all of them are up and operational, but within the hackathon, we work mainly with, or for sure with Sentinel-2, maybe with Sentinel-5, or even at the later stage also with Sentinel-1. On the other side, we also help everyone to process and to access the data. So you have a lot of many different types of tools. And we will also give you a short introduction on how you can give and access the easiest these data, and how you can use and display them or even process it. Here, I would also like to show you a brief example that we are using, or that we had within our consultation that we had within the National Point of Contact at the University of Zurich. So what you can see here, again, green means vegetation in this case. However, we look also at different bands and so-called vegetation indices to see where we have more humidity or less humidity than a certain average. So what you can see here, this is the Alton area, and in red you see the train tracks. So as we were working with the Swiss Railway company, we were interested in the tracks. That's why they are red, but red is the same color as purple, or means the same. So purple is like everything that we would expect is either white, like as wet as we would expect it. Purple is rather drier. And then what we were interested is the areas that were wetter than what we would have expected. And everything that is blue or green is wetter than the reference, and everything that is purple is drier. So what you can see in this zoomed area is that there is a little area next to the train tracks in red, where you have this blue spot where there is more water than what we would expect, meaning that from the reference time, something had happened that now there is more water. And with that, we could say, okay, now maybe you have to go have a look. Maybe there's too much water, so there is something wrong in the drainage system of the train tracks. And on the other side, what you can also see is these green areas. This is mainly what you might have even already guessed. This is mainly agricultural field. So there it's a bit different as it's changing, the crop cycles are changing, so on. So it's not unexpected that they are partly more humid than others. Another example, this time not from Switzerland, but still also regarding forest, actually, which was a master thesis that we had in Ethiopia. So with satellite images, you can go wherever you want. And this time it was also Landsat data. That's just the same satellite that the Europeans have, but just from NASA, some from the Americans, but the time series is a bit longer. So what you see on the left side was we classified the land cover. So what's the surface land cover, meaning be it forest, shrubland, grassland, whatever. And then on the right side, we wanted to know where we had forest loss and forest gain. So green is forest gain, meaning that there is more forest between two reference times, and red, there was the deforestation. That means they cut forest. And these are also tools where we can really monitor over a longer time series what had happened with the trees and with the forest, what already Devis showed you. So there's a lot of application spatially distributed regarding the forest. And as a last example, I would also like to show you something that we had a project with the Swiss Red Cross. So we there looked at a completely different data sets that was related to water. So that means the question was, can they predict when they have strong rainfall that they have some floods in certain areas? So we also helped them to develop a tool that they know from satellite data where they have rainfall, and then to predict at another, maybe another place, how much water will then arrive, and if it's dangerous for this area, and if yes, they could already think about help. Is there help needed or not to help the local people? And again, this was also an application that was done globally, so everywhere in the world, thanks to the satellite data. So with these few examples, I hoped to give you a small ideas or inputs about how you can use the data. But in particular, I want to highlight that we will introduce you tomorrow to the data sets available, different ones. So if in today's presentation you do not really understand what we have done with these data sets or what Sentinel data is and why the numbers and so on, just join tomorrow the webinar as well, and we will give you more details on everything that will be available for the hackathon. Thanks for your attention. And then I give back to Nina.
Thank you very much, Claudia, for this presentation. And yes, as you already said, tomorrow there will be the presentation of the Swiss dataset, and Claudia will also be there to give us more information on it. But thank you, first of all, for introducing the National Point of Contact to us and also its activities at the University of Zurich. Our next speaker is Dr. Reik, the co-director of the Science Lab at the University of Zurich as well. The Science Lab, UCH, is a science communication and outreach program from the science faculty of the University of Zurich. Reik, are you ready?
I'm ready. Okay, so also welcome from my side. So I will shortly present the Science Lab UZH, but first some words to me. So I'm Reik Leiterer, and my background is in geoinformatics and Earth observation. So I'm now active since 15 years in this field. I really like to work with satellite data, dealing and solving problems and challenges in the field of environment, in particular in changing environment. So like detecting deforestation, quantifying melting ice somewhere in the Tibetan Plateau, analyzing air quality, or also use LiDAR data, which was my PhD thesis, to extract the structure of a forest and what you can know and learn about the forest and the forest health and the forest development just by the structure. I somehow really fell in love with this data, with this topic. So I decided to continue with Earth observation, but in a slightly different setup, because I want to talk about it and teach other people about this beautiful field. So I moved to the Science Lab UZH, which is indeed a science communication and outreach center, funded, financed by the science faculty of the University of Zurich, and is mainly active in reaching out for high school students, but also for the wider public. So a lot of events we are doing, participating, organizing, and our main topics we deal with is science and sustainability. So how you can link all these nice research from chemistry, physics, math, geography, biology to the Sustainable Development Goals of the United Nations. This is pretty important from our point of view, because we need to think about the future, and for this we need to understand how science can help to develop in a sustainable way. Luckily, there are also technology developments to help and to contribute to the sustainable development. And this is related to the next topic, the digital skills. So as you all know, we are living in an area of digital transformation. So we have data which was not available years ago. We have computational resources, which is just awesome. The people are connected in a way which never ever happened in the mankind human history before. So all these leads to a lot of development in terms of social behavior, connection, communication, and also open innovation. And that's something like these hackathons where you create innovation, and it's just possible because you can work together even if you're not sitting on the same table. You can access data from everywhere in the world. You can link it. You can calculate the data somewhere on the cloud, store it, share it to other people. So it's just awesome. It's amazing. But you should also be critical about this. So just think about data protection, privacy. Just think about all these cool data. Are they really unbiased, or is there some intention in the data? Are they complete, or is there some gaps? So there's this famous data gap stuff. Is there a bias in the algorithms you are using? Because everyone who is creating an algorithm, he is developing his algorithm based on his experience, but maybe it's not the best one. So all these critical thinking is pretty important if you're working with data, with a lot of data, with open data, as maybe the transparency of the data origin not so clear, but also in applying the data. So what is if you can detect some really heavy disturbances of some industry? Should communicate it to the wider public or not? What is if you see that some countries doing stuff which is maybe against human rights? So it's also a question of responsibility you have based on your skills, the data, your knowledge you have. But all these together, if you have a pretty good skill set, you are somehow pushed to be innovative. You have good ideas, you have pretty good skills, competences, you can work and turn out the ideas in something which other people can use in some product or services. And then if you apply it and people realize it's good, I want to use it, then we are in the field of innovation. So there's several definitions of innovation, but in general, transfer from the research knowledge to something in industry which is highly accepted by the market, then you are in the field of innovation. That's awesome. And that's something I also realized. So some colleagues and me, we started with a spin-off dealing with Earth observation in the field of environment, and that's something we started directly from the usage age. So we created ExoLabs. It's a company working in the field of Earth observation. So we are using satellite data with a focus on the free available satellite data you will also work on, like the Sentinels or the Landsat and MODIS satellite data from the American space agencies. So we're using this data, and then we apply these magic unicorn machine learning, artificial intelligence to the data to get added value out of it. So creating some information based on these poor measurements. Because the image is nothing else than reflected energy or backscattered energy from the sun or from a satellite. So there's not really information. So to move the information, to move the measurement into information and then into knowledge, it's something what we are doing. So we are providing a thematic information layer in the field of environmental monitoring. So we are dealing with forests, with cropland, with snow, with water, and providing it as a service to industry. And that's maybe the main difference to research. In research, it stops with, we have nice data, we have nice algorithms, we make a beautiful product, and it's enough. You can publish it. But maybe it not works just in another country. Maybe it not works with a different data set. In industry, you need to have a more robust, more stable algorithm which works in other countries, which also can handle if some satellite fails and stop working. And of course, the access, the service point, it's pretty important. So in science and research, you not care if people can really easy access your data. You put it somewhere on the FTP and it's done. If you want to make business with your data, you need to just know what's the current state of art in data access. So I'm talking about all the APIs so that you provide the data in an easy way that they can be integrated in other products, platforms, services, which is not so straightforward for a lot of customers, but it will come for sure. And most of the people applying and registering for these hackathon, of course, they are expert in this technical domain. So they should also, or you should also consider the access to your idea, to your service, to your product should be state of the art. And also like the processing, think in a sustainable way, also from a business point of view. It should be cheap, it should be scalable, it should be highly protected in terms of uptime. So it should be a really stable environment where you are processed. So it's pretty hard to avoid working in the cloud using one of these many cloud providers. And you should think about because it's in the field of Earth observation, the data are big and you get a lot of data and really fast in a really short time period. So with local solutions, you will run into some limitations for sure. And that's actually what I want to give you then during this hackathon, this view from science to business, and what are the challenges, what are the advantages, and what is the beauty actually of Earth observation, and how you can transform your scientific knowledge, your technology knowledge, in some real impact to change something in the world, to support something which can move us in the right direction in the future. That's it from my side. Looking forward to working with you.
Thank you very much, Reik, for this presentation and also for going a bit deeper into the topic. What is the difference between using data for research and using data as well for business? So thank you very much. Reik will also be with us on Thursday to help you to find your teams and to find a project and support us further with this. Thank you very much. Our final speaker is Raphael Roettgen. He's the founder and managing partner of E2MC Ventures, and he's also a member, a venture partner of Space for Impact. Raphael, are you ready?
Well, it's actually just going to be myself talking. I didn't bring any slides today. I also realized I am the last speaker, and it's a if people are based here in Switzerland and Zurich, it's an absolutely fantastic day. So I'm the last thing that stands between you and a happy hour on the lake. So I'm not going to speak for a very long time here. I basically just want to make 2 points, I think, from a investor point of view. And as Nina said, I'm the managing partner of something called E2MC. And E2MC is a space specialized venture investor, and we invest at the seed stage, so in very young companies. And we do that globally, actually, but certainly also in Europe. And we certainly look at a lot of downstream companies and Earth observation, some companies that use GNSS as well, geolocation. And a couple of things here, and let's maybe use the example of remote sensing. First, the good news. The good news is that many investors, including ourselves, actually like downstream Earth observation as an activity. And why is that? Because compared to, well, there's several reasons, but one big reason is that compared to several other activities and business models in space, like, for example, launch or putting up entire satellite constellations or so forth, it is basically much less capital intensive, right? I mean, think about it. If you start a new rocket company, pretty much nobody has done it spending less than a few $100 million. And if you put up a satellite constellation, that's typically at least a few $100 million. If you start a downstream Earth observation company, you don't need any hardware, right? I mean, basically, typically you need a bunch of data scientists. You may have to buy data, but then as we've learned, and it's a big point of this hackathon, obviously, a lot of the data is actually available for free. And then you probably need some processing time, which you can rent basically by the instance from people like AWS. And if you're a startup, they will probably give you a lot of free credits as well. So there's very little capital intensity, and that's one reason why investors like it. Another reason is that if you find something that's has a valid use case, and we'll come back to that in a minute, you can possibly get to revenue very quickly. And again, that makes it very different from a lot of other space businesses, where sometimes it may take years until you get to the stage where you can actually make some revenues. Okay, so that's the good news. Let's come to the, I don't want to say bad news, but sort of like the caveats or something to keep in mind. And actually, some of that has already been effectively mentioned by Reik. And I'm thankful he did that, which is, I tell you what the main problem is with most of the business plans that cross my desk, my partner's desk, that are related. Again, let's use downstream remote sensing as an example. And that's the following. Most space companies or space-related companies at the moment tend to be founded by space-related people. So space engineers, aeroastro engineers, mechanical engineers with a space minor, people like that. In general, people who are from a technical background and get very excited, and sometimes, so often for valid reasons, get very excited about the technology and like the sensors, the data they use and the sensors to produce the data and so forth. The problem with that is if you're downstream, typically, well, actually, I think always, you're supposed to produce data for a specific use case for a specific customer group. And that customer group, whether that's farmers or insurance companies or cities or other industries, they pretty much don't care that the data comes from space. They just care about having usable insights that they can use in their day-to-day business. And that's actually where most of the business plans and the execution models we see fail. They focus way too much on the technology, or what we call the feasibility. And they don't actually focus enough on what we would call the desirability. Is this actually useful to somebody? And then equally important, is somebody happy to pay money for this? And they also don't, related to that point, they also don't focus enough on what we call the viability, specifically economic viability, which is, well, okay, even if somebody is paying you money for this, are they paying you enough? Do they cover your cost? Is there a long-term business here? And that's really something when we look at these business models, we want to make sure that all of these 3 points are covered, that it's a desirable product, that obviously it's a feasible product, that, data exists, that's usable, and the data can be analyzed, and that, we have good algorithms and all of that. And then also the economic viability, can this actually be turned into a business? And then from our perspective, of course, a business that's ideally very scalable and that can produce interesting returns for us as an investor. And that's certainly something that I'm always on the outlook for, and certainly also be quite happy to help people in the hackathon to think about these topics. Just a couple of points I wanted to basically mention. Again, one positive, it's a business model that people like, and the second, just to be careful about making sure it's something that customers can actually use and you can turn it into a business.
Okay, thank you very much for these insights, Raphael. And yes, also thank you for being on board for us to help us out as a mentor for the business cases that the participants will have to submit. So yes, this has actually been already the final presentation of today. We hope you were able to learn a lot. Again, we will upload this presentation to be announced. It will be available on YouTube, and we will send you the links as well on Discord, so you can watch specific sections again, or also send it to your teammates in case they didn't have time to catch it. With this, I would like to thank everyone for attending this session, also to the speakers, to you, the viewers, and we wish again to see you tomorrow. Thank you very much.